Hello Internet! Today I like to continue my talk about the use of GRBL and GCode for desktop or consumer CNC machines. In the last video we covered some important GCode and GRBL topics. Today's focus is on manual programming with GCode for linear interpolation movement, to get a better understanding of how a CNC machine works. I will show you useful details and we will do some manual GCode programming to get a better understanding of GCode. But I highly recommend my last video, which explains basic GRBL and GCode details or the CNC hardware and software setup. I will add a link right here in the video. Keep in mind, this is just a demonstration how I do work with GCode on my machine. Be very careful and check your machine documentation to understand the abilities of your machine. Again, we have a lot to cover, therefore let's start. When we turn on the machine lists the current GRBL settings on the console. If we use the non-GCode command $G, we can see the current status of the modal GCode commands. For example, G54 tells us that we are using the register G54 to define the coordinates of the work coordinate system origin. To see the current GCode parameters, we can use $# command and see the current position data. To use them, we need to initialize the machine coordinate system to give the machine a reference position. To do this, we use $H command and perform a homing cycle. After the homing cycle, the machine coordinate system origin is set and all further movements refer to this origin. Now we can use the already stored parameters and, for example, move to the safe position stored in the G28 register. Therefore, we use the command G28. Check the current parameter position and see how the machine moves to the position stored in G28. Let's move the spindle to the origin stored in the parameter register G54. Therefore, we'll use GO, rapid movement, with the command GOXOYO. This moves the machine to the origin of the work coordinate system stored in G54. If we want to prepare for a later milling operation, we can already use F800 and S10000 to set the feed rate to 800 mm per minute and a spindle speed to 10,000 revolutions per minute. Since these are modal commands, the machine remembers the states until you turn the machine off, and you can change the values at any time. Now I set the tip of the milling bit to the surface plane by moving the Z-axis in smaller and smaller increments. When I'm happy with the level of the router bit, I just can save the Z-axis height or the complete X, Y and Z coordinates in the G54 register using G10, L20, PO, XO, YO, ZO. This uses the current position and stores it in the G54 register. The L20 parameter takes the current position and the PO and P1 parameters reference the G54 register, where PO references the default register and the P1 parameter references explicitly G54. It is a good idea to move the Z-axis to a safe Z position for free movement without any obstacles later on. Now that I have my machine set up, let's look at the current settings. I turn the router on using the M3 command, and now I can start milling using G1 linear interpolated motion mode with the currently set feed rate and spindle rate. The machine is in absolute positioning state, G90, and we need to use absolute positions in the code to tell the machine where to move. Look at the sketch and compare it to the G1 commands here. Now we switch on the router spindle with GCode M3 and start milling the rectangle with the absolute positioning G90 and the depth of 2 mm. GCode G01 uses the feed rate to move the router spindle and the current spindle rate to set the current revolutions per minute of the spindle. G01 expects the next endpoint as a parameter based on the current work coordinate system. The CNC control moves the spindle in a linear motion to this point in 3D space. After all, I can mill a second rectangle, but now we're using incremental move mode. And now let's go to a new start position. Again, we will define the next endpoint as a parameter using GCode G01, but now as a relative distance from the current position. The CNC controller will then move the machine to the new calculated endpoint in 3D space using a linear motion. As always at the end, let's raise the Z-axis to safe position and use M5 to switch off the router. To sum it all up, take a look at some GCode syntax variants. The commands can be entered line by line or can be combined. Note that the modal state remains active until the state is explicitly changed. Here are some examples. Have a look into the state window and see how the individual commands change the modal state. The current work coordinate system can also be addressed in the line, so different origins can be easily used during processing. Let's have a look into the console window of the Universal GCode Center software. Check the current GCode parameter settings, which are displayed here using the $# command. I have already set up various work coordinate systems, as you can see in the parameter settings, and can therefore use them with the GCode G01. Each G01 command makes the router jumping to the origin coordinate at XO, YO, using the addressed work coordinate system in the parameter set, for example from G54 to G59. It should be noted that each CNC machine, or better CNC controller, may have a different implementation of the GRBL standard. Therefore, make sure you know your machine and how it works. That's it for today. I hope this helps you better understand GCode programming. The next video will cover circular motion programming with different parameterization types. The video is already in the production pipeline and should be available soon. As always, if you have any questions, let me know in the comments. And if you might want to improve something, let me know. I'm always open for constructive feedback. That's all for today. Thanks for watching. Bye, Freetown.